Let me terminate this lesson by comparing functional and imperative loops in functional paradigm and in an imperative paradigm. So what we saw in this lesson is that if you want to do a loop in the functional paradigm, you have to write it as follows. You have to write it as a conditional with a condition is done to say when it's done, and if it's not done, with the recursive call that is the last operation. The argument here is the state of the loop, and is done is a function on the state. Here we were just returning the state. And finally, when we go to the iteration, we transform the state into the state of the next iteration. So in all the examples we saw, the state combines both the part of the recursive call that decreases and the part that increases. It combines it in one package. So this shows you the overall schema. Now, in the imperative paradigm, imperative being a paradigm where variables can be assigned multiple times, the loop looks something like this. So this is a syntax similar to C++ or Java. We also have a state here with a small letter s. We have here, while not is done, we do s gets the value of transform s. Notice we're using the multiple assignment here. And so this loop here is doing exactly the same as one iteration of the Taylor recursive function. And when the condition is done is true, here we return s, the state of the transformation. So you see that the loops are actually identical. It's just a difference in syntax. And in both cases, if you want to do a correct loop, you should use invariant programming.